Good morning. So, yeah, this is going to be a quick video. This is just about basically looking at why when a neutron or proton, an atom, but it will be a neutron because it will have been compacted by gravity into a neutron by the time it gets very close to an event horizon. But here's a neutron. So here's a thing in no gravity, right, and not moving. There's a little ping. Let's just say it's emitting a photon. We're just going to use that as a sort of a gradient for space-time around it, right? Then you start to move. And because you started moving, you sort of squished space-time, as we call it, in this direction, right? And extended it in that direction. You'd have a red shift and a blue shift, right? Makes sense. Okay. And then, so let's just say that this is, you're in no gravity and you're standing still, or you're in a gravity field, but you're holding still relatively. Here's you moving. You know, you're in a really good spaceship. That you've got relativistic effect at all. Okay? And then you are now moving at the speed here. You are now moving at the speed of light, because you've been excited to the speed of light by the gravity of the event horizon. And notice that, like, at that point, all lines, like, it doesn't even matter what time, when you emitted that, how far away was that before? It's all bunched up. You are the vacuum energy. It seems pretty inevitable to me. It's like you become the energy of the universe. This is like the layer that everything is a reflection of, or sort of, where the interference pattern, but this is the actual under layer. This is like the Marangoni current. Like when you have a membrane, there's actually two membranes usually, and a membrane consists of this like weird fluidy dynamic part. And then here's the part that we see, and here's the part that we see. And that's the part that's sticking out, that reflects. And that's what you see in terms of the swirls on a bubble, right? But in between, there's a whole bunch of stuff going on in here. It's like the rotations of all the stuff. And that's exactly what the vacuum flux is. Boop, this is light. And then, so now you become the vacuum flux. Time doesn't even matter because space, everything is just compressed. You're everything at the same time, which we just demonstrated. Okay, so how long does it take for you to get to the easiest place to fall out of space, which is where there's the least energy, which is deep voids of space, which we can't see because of what's coming out is a neutron and then decaying, and not a neutron, decay, proton, electron-y field, but it's not in a nice orbit yet. Okay, it's amorphous. It's always described as like amorphous content in a book, but if you had a bunch of that together, what does it amount to? It amounts to dark matter. Okay, and then eventually the dark matter stabilizes and becomes hydrogen. And now that it's hydrogen, it can emit photons and absorb photons. And even then, it's still very hard to detect, as a couple of articles I've posted indicate. So this is just the logical sequence this is what the core of this video is supposed to be. Basically just like the logical consequences. Like, of course you become the vacuum flux. Where else do you think you are when you hit that speed? You're everywhere. This is like the geometry of it. It's like you're everywhere. Okay, and then you reemerge. And you are a neutron, the most condensed form of matter, in the least dense environment possible, deep void of space. You decay, because that's what you do. Because you don't have a gravitational field holding you together as a neutron anymore. So now you decay into a hydrogen, because that's That's the phase change. The phase change is between hydrogen and a neutron. Hydrogen and a neutron. This is the essential phase change of the universe. Okay, and it's like that phase change that powers the whole thing, that and gravity. Neutron decay cosmology. Anyways, peace. Have a beautiful day. Later.